Okay, hi everybody. Today we will continue with the title of product of a matrix and the types of a matrix as well as some algebraic properties, the transpose of a matrix. Now as we know that null or zero matrix is simply a matrix in which all of the entries are zero and such matrix are zero matrix. The order of such matrix may be m by n, or it may be equal. That means it may be 1 by 1, 2 by 2, or in any orders. But it must be all of the entries should be what? Zero. Now let us we continue what means square matrix. Now it said that an matrix or a matrix is said to be square matrix of order n. An this matrix An matrix is said to be square matrix of order n if m is equals to n. That means if it has the same number of columns and rows. If the number of rows and the columns of a matrix are equal, then the matrix is square matrix. For example, this matrix 2, 3, 0, 5, 1, 2, 9, 0, 6. This matrix was 3 by 3. Therefore, this is a particular example of square matrix of order 3 by 3 because the number of rows of this matrix is 3 and the number of columns of this matrix is 3. The number of rows in the columns are equal. Therefore, this matrix is a square matrix. And also, this matrix for at 12, 16 is also a particular example of square matrix of order 2 by 2. And square matrix of order n. The entries which lie on the diagonal extending from the left upper corner A11 to the lower right corner ANN are called the main diagonal entries, or more simply, which is called main diagonal, or in other ways they are said to be principal diagonal. Definitions: the sum of the entries on the main diagonal of square matrix is equal to aij of order n by n of order n is called trace of A. That means trace of matrix A is given as summation of aii, where I runs from 1 up to n. It means that this is the same as a11 plus a22 plus ann. This is which is trace of matrix A. Note that we can find trace of matrix A if and only if the matrix should be what? Square matrix. For example, consider matrix A, which is 2, 3, 5, 5, 3, 2, 4, 0, 7. Now the trace of this matrix is which is 2 plus 3 plus 7. Therefore, trace of matrix A is which is 12. Let us see another types of matrix which is called a triangular matrix. Now, what means triangular matrix? And there are different types of triangular matrix, and also now what means triangular matrix? The definitions: square matrix is said to be an upper triangular matrix if all entries below the main diagonal are zeros. And a square matrix is said to be a lower triangular matrix if all entries above main diagonal are zero. And a square matrix aij whose element aij is equal to 0 whenever I less than j is called a lower triangular matrix. This is the definitions or how we can understand in a short method. Now, in triangular matrix, there are two types of triangular matrix, lower and upper triangular matrix. Here a lower triangular matrix simply entries in which all aij are 0 whenever I less than j is called lower triangular matrix, and aij whose entries aij is equal to 0 whenever I greater than j is called upper triangular matrix. Or you should have to follow this definition. Square matrix is said to be upper triangular matrix if all entries below the main diagonal are zeros. And square matrix is said to be lower triangular matrix if all entries above the main diagonal are 0. Or you may follow these short and precise definitions. For example, matrix which is given as like this 2, 3, 5, 0, 3, 2, 0, 0, 7. This is, if you observe that this is the main diagonals, which is the main diagonal entries of this matrix is what? 2, 3, 7. Now below this, below main diagonal entries, all entries are 0. Then we say just this is what? One of the example of upper triangular matrix. And also if you see this matrix, this is a square matrix, and the main diagonal entries of this matrix are 2, 0, 7. And above those main diagonal entries, these all are what? 0. Then we say that this matrix is a lower triangular matrix. Another types of matrix is called, which is diagonal matrix. Now, what is diagonal matrix? A square matrix whose every element other than the diagonal elements aii is 0 is called diagonal matrix. Therefore, a diagonal matrix is simply a square matrix in which all entries are 0 except that of the main diagonal entries. But different books say that whatever it is the main diagonal entries. So generally, square matrix in which all entries, all non-diagonal entries are 0, then that matrix said to be a diagonal matrix. For example, such matrix, or simply we can understand as like this: square matrix whose every element other than diagonal element aii 0 is called diagonal matrix. D matrix D is given as d11 0 0 blah 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 0 0 d22 blah 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 0 blah 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 0 0 0 dnn. Now here, this is the main diagonal entries of this matrix are what? d11 d22 dnn. All of non-diagonal entries are 0. Then this matrix is, which is a diagonal matrix. For example, matrix D is given as like this: 2 0 0 3 0 0 3 0 0 0 7. That means this matrix is an example of diagonal matrix. Why? This matrix is square matrix plus all entries except those main diagonal entries are 0. Or in other words, this is square matrix and all non-diagonal or off-diagonal entries are 0. So that this matrix is what? A diagonal matrix. Another type of matrix is called, which is a scalar matrix. A scalar matrix can be defined as a diagonal matrix whose all diagonal elements are equal is called a scalar matrix. Here, this matrix is square matrix, or this matrix is a diagonal matrix in which all of or all non-diagonal entries are 0, and all of those the main diagonal entries are the same, which is C, 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 C. Therefore, this matrix is what? Which is a scalar matrix. For example, this matrix 4 0 0 4 0 0 0 4. Now here we observe that this matrix is a diagonal matrix, and also all of the main diagonal entries are equal, or which is the same, which is 4 4. And also this matrix is a diagonal matrix, is a zero matrix, is a square matrix, and also this matrix is a scalar matrix. Because to be zero matrix, all of the entries should be zero, which it satisfies. And this matrix to be square matrix, the number of columns and rows should be equal, here which is equal, which is 3 by 3. And this matrix to be scalar matrix, this matrix first is what? A diagonal matrix, and all of diagonal matrix are zeros, and this matrix are scalar. Another one is this 1 0 0 1. Also, this is also which is scalar matrix as well as diagonal matrix. Definitions. A square matrix is said to be identity matrix or unit matrix if all its main diagonal entries are ones and all other entries are zeros. In other words, a diagonal matrix whose all main diagonal elements are equal to 1 is called identity or a unit matrix. And an identity matrix of order n is denoted as like this n or simply I. Here in is given us which is 1 0 0 0 1 0 0 0 0 1. Now this is which is called identity matrix, or we can define as identity matrix is scalar matrix in which all the main diagonal entries are 1. For example, such matrix 1 0 0 1 0 0 0 1. This is an example of identity matrix of order 3. Another one is transpose of a matrix. What is transpose of a matrix? What is its properties of those transpose of matrix? Definition: let matrix A, Aij of order m by n be an m by n matrix. The transpose of A is denoted by A raised to t. Is a matrix which is obtained from A by interchanging the rows and the columns of A. Thus, the first row of A is the first column of A transpose. The second row of A is the second column of A transpose, and so on. That is, A transpose is the same as AJI of order n by m. Means that, in short, if matrix A is given as Aij of order m by n, then A transpose is a matrix of with entries AJI of order n by m. For example, matrix A which is given as -2 1 3 2 0 4 7 5 6, then A transpose is simply obtained by interchanging the row and the columns. Interchange or write a row of A as A transpose column for A transpose, and that means first row for A is first column for A transpose, second row for A is second column for A transpose, third row for A is third column for A transpose. Therefore, -2 1 3 is as row, and now we write as a column here, and 2 0 4 as a column as row for matrix A. The carrot its column for A transpose, which is 2 0 4 7 5 6 for row of matrix A, then we can write as column for A transpose, which is 7 5 6. Note that A transpose is given as itself matrix A. Properties as property say that let A and B be a matrix over a real number R, and alpha is an element of a real number. Then one, A transpose is the same as A. And A plus B's whole transpose is A transpose plus B transpose, and Alpha A the whole transpose is the same as alpha times A transpose. Alpha times B the whole transpose is B transpose times A transpose. This is which is transpose of a matrix. What is symmetric? A skew symmetric of a matrix, and how we can define it. Now, a square matrix A is here to be a symmetric matrix if A transpose is the same as A. Or in other words, if A transpose minus A is zero matrix, then the matrix is symmetric. That in other ways, this means the element of matrix A are symmetrically placed about the principal diagonal. That means if Aij is equal to Aj. For example, matrix A minus 2, 1, 3, 1, 0, 4, 3, 4, 6. This is one of example of a symmetric matrix by a transpose of transpose of this matrix is which is minus 2, 1, 3, 2, 0, 4. 7, no, this is minus 2, 1, 3, and since matrix A, that means this is error of writing, or this is to write what, or to interchange, that's minus 2, 1, 3, 2, 0, 4. That means by interchanging this minus 2, okay, this is another example. Now this example says that this is minus 2, 1, 3, 1, 0, 4, 3, 4, 6 is an example of symmetric matrix. Why? Let's observe that this the main diagonal entries of this matrix are what? Minus 2, 0, 6. And let's say that this diagonal is here 1, 1, 3, 3, 4, 4. They are what? Positive. Both of those diagonals, they are positive. So this matrix is which is symmetric matrix. Or in other ways, find transpose of this matrix and you obtain as itself matrix A. Then this is symmetric matrix. Another definition is which is deals about skew-symmetric. How we can define skew-symmetric. Now, square matrix A is said to be skew-symmetric matrix if A transpose is equal to minus A. That means Aj is equal to minus Aij. For example, 0, 1, 3, minus 1, 0, 4, minus 3, minus 4, 0 is a particular example of skew-symmetric matrix. Why? I observe that, as I told you, that this is the main diagonal entries are what, which is 0, 0. Now taking this 0, 0 and observe that this the diagonal here, 1 minus 1, 3 minus 3, 4 minus 4. They are what? Opposite to each other. That means A12 is the same as minus A21. A13 is the same as minus A31. A23 is the same as minus A32. So this matrix is which is skew-symmetric. Or in other ways, the transpose of this matrix is which is given as 0 minus 1 minus 3, 1 0 minus 4, 3 4 0. Now taking negative as a common, we obtain as minus of the matrix 0 1 3 minus 1 0 4 minus 3 minus 4 0. This is which is A, then minus A. Therefore A transpose is equal to minus A. Then as a result, this matrix is which is skew-symmetric matrix. What are the properties of this skew-symmetric matrix? Now, the properties of skew-symmetric matrix say that the above definitions, that means implies that symmetric matrix and the skew-symmetric matrix are square matrix. Yeah, skew or can find skew-symmetric or symmetric matrix for square matrix. And it says that for any skew matrix, A A plus A transpose is symmetric, and A minus A transpose is, which is skew symmetric matrix. No. This should be interchanged, because since as we know that A plus A is equals, if matrix A is the same as A transpose, then the matrix is symmetric. Therefore, if we take this to the left side, then A plus A transpose is for skew-symmetric, and A minus A transpose is for symmetric. Therefore, the definition is interchanged. Sorry for typing of error. So take as this symmetric as skew-symmetric, and skew-symmetric as symmetric matrix. Number 3, if A and B are two symmetric or skew-symmetric matrices of the same order, then so is A plus B. That means if A and B are two symmetric or skew-symmetric, then A plus B is also, which is symmetric or skew-symmetric. If A is symmetric or skew-symmetric, then alpha times A is also skew or symmetric or skew-symmetric matrix. And let A and B be symmetric matrix of the same order, then the product of A times B is also a symmetric if and only if A times B is equals B times A. The product of two symmetric matrix is not general symmetric. That means for A transpose is equals to A and B transpose is equals to B, we have that AB the whole transpose is B transpose times A transpose, but B times A is not equal with A times B. However, if A is symmetric matrix of order n and B is general of n by m matrix, then B transpose times A is symmetric of order m. That means for B transpose AB, the whole transpose is, which is B transpose by transpose times A transpose times B transpose transpose, which is given like this. This is the same as, since B transpose transpose is B, therefore we have what? B transpose times, since matrix A is symmetric, therefore A transpose is the same as A, therefore we have that B transpose times A times B. Another one is elementary row or column operations, should be discussed in another part. Thanks for watching my video, but don't forget to subscribe, like, share, and comment my channel.